Hello and welcome back to Dr. Logic Awkwardly Does Logic while trying not to curse too much at Zoom because that's not very professional. In this video, I'm going to introduce the second of our derived rules, disjunctive syllogism. But don't be surprised, don't be confused. Disjunctive syllogism doesn't actually have anything to do with syllogisms. It does have a lot to do with disjunctions. And in fact, disjunctive syllogism's main claim to fame is that it will allow us to not use disjunctive elimination in many, many cases. Disjunction elimination is one of the rules that people struggle with the most. So if you've been finding it unintuitive and difficult and hard to apply, don't worry. Lots of us don't like it. Disjunctive syllogism will allow you to dispense with that rule in not all, but probably about 3/4 of the cases where you would have used disjunction elimination. So let me bring up my whiteboard and talk you through the rule. So the idea is that if we have a disjunction and we know that one of the disjuncts is false, well, then the other one has to be the one that's true. So thinking at the level of proofs, if we have a disjunction between, say, phi and psi, and we know, say, not phi, well, then it has to be the other one. In fact, this rule is just a formalization of the fifth undemonstrated Stoic argument that says either the first or the second, not the first, therefore the second. Except because disjunctions are symmetric, we're going to actually have two versions of the rule depending on whether we are negating the left-hand disjunct or the right hand. So in that case, in that sense, it's like disjunction introduction and conjunction elimination. Let me give you the schematic form of it. So this is disjunctive syllogism, or we will abbreviate it DS. So suppose you've got a proof. On some line I, you have a disjunction, phi or psi. Some later line of the proof, line J, you actually have not psi, so the negation of the right-hand disjunct. Then on line N, you can write down phi, and the annotation is disjunctive syllogism, lines I and J. The other version of it starts from the same starting point, line I, you've got some disjunction phi or psi, except this time on line J, what you have is the negation of the left-hand disjunct, so not the right-hand one. But that means on line N, you can conclude psi, the right-hand disjunct, and exactly the same annotation, disjunctive syllogisms, lines I and J. So there's the schematic form of the rule. Let me write it down so that you've also got the written version. So if in a proof you have a disjunction phi or psi on line I, and the negation of one of the disjuncts, so either not phi or not psi, on line J, where just our usual little bookkeeping, lines I and J can't be the same line. I has to come in the proof before N, J has to come in the proof before N. Then on line N, you can write down the other disjunct. So in the case where we have not phi, that means we can write down psi. In the case where we have not psi, we can write down phi. And the annotation in both cases is disjunctive syllogisms, lines I and J. So there you have it. It's a very straightforward and intuitive sort of rule in a way that disjunction elimination is not. Now, I said in the video on modus tollens that anything that you can prove with modus tollens, you can prove without it. And I gave you a demonstration of this. Now, the same thing is true with disjunctive syllogism. So anything you can prove with disjunctive syllogisms, you could prove without it using or elimination instead. Now, I'm not going to give you a proof of this. I'm going to leave this as dun dun dun, an exercise for the viewer. So this is your chance to put together all of the different things that we've been talking about and learning how all the basic rules work together, what it would mean to prove one of the derived rules with just from the basic rules, all of these together to show that you don't actually need disjunctive syllogism. You don't get anything new from it. You just get simpler, easier proofs. So give it a go. And if you've got any questions or you would like to check your answer to see if you're on the right track, leave a comment. You might not be able to actually demonstrate your proof in the comments unless you are able to represent logical proofs in ASCII, in which case, go you. But you could also send me an email or find me on Twitter, and I would be happy to take a look at any of your attempts at this exercise. Next time, we will talk about the replacement rules. So the ones that allow us to operate not just at the level of formulas written on lines, but at subformulas of those formulas. And well, we will have a lot of fun because we always have fun, don't we? Anyway, take care and see you then. Cheers.